Great. So good afternoon all, and welcome to the another lecture of semester one electronics, in which we are supposed to learn about some of the basic components of electronics, hopefully passive components. And we have started with the resistances, capacitances, and inductances. Like, in fact, we have completed all those three. And let us start to recall what we have studied in the earlier classes. So we'll begin with this. Uh, I guess my screen is visible, my presentation is visible to you. Uh, is it fine? Right. So good
Yes,
afternoon
sir.
all. Let me introduce myself. Dr. Nilesh Meshram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today we are going to study about the transformers that we are expecting to study today. So let us begin with that. I guess what we have studied in the earlier class, just refresh it a little bit. So we have started with some of the electromagnetic concepts that were concerned with. Okay. Just hold it for a second. I guess I have put it somewhere early in the lecture. Yes. Okay. Just hold for a second. Yes, it will be. And I guess, yeah, I should put over here. Right. So, yeah, in the earlier class, what we have studied was some of the inductors, cylindrical inductors, and their characteristics. How to these are some of the variants of inductors that are available in the market. These are some of antenna coils which we use as antenna. These are tuning coils. So these all are the say inductors which we use in different forms. These are some chokes, and these are toroidal coil which are in circular in shape. So this is what we have completed. These are some of the symbols of inductors that we need to draw while drawing a circuit. So these are this is air core, this is iron core, this is powered iron core, and this is variable core, right? So if you can vary the core itself, core means the area inside the coil, that is called as a core. So we'll study in that. So today we have to start with the basics of transformer, right? So electromagnetic concepts. What are the concepts of electromagnetic? As the name suggests, it is a magnet which is being developed, or which is being arranged according to the electric field applied to it. So whenever current carrying conductor is supplied with a AC voltage or a current, then the EMF is generated through that coil, right? And a magnetic field is develops across it. So magnet, you understand what is a magnet. So electromagnet consists of an iron core in placed inside a wire coil. So coil के अंदर we put a say a iron core, एक लोहे का टुकड़ा हम उसमें रखते हैं और उसके ऊपर हम लोग कॉइल वाउंड करते हैं. और जैसे ही हम लोग उसमें से करंट पास करते हैं तो ये जो आयरन का टुकड़ा अंदर है, इट बिकम्स अ मैग्नेट, and that is called as a electromagnet, and the field which is generated due to this is called as electromagnetic field. The magnetic field strength of a wire coil carrying an electric current increases in direct proportion to the number of turns of the coil. So as we go on increasing the number of turns on that core or on that iron piece, the magnetic field also gets increased, right? So that is the crux of the electromagnetic concept. So remember this: whenever we have a coil and whenever we put iron core inside that core, inside that coil, so it becomes a magnet. That particular iron piece becomes a magnet. This is the basic concept of electromagnetic field. Now the another concept of electromagnetic field, we have studied this inductors, and we have studied this in very depth. So we have completed all this. Yeah, I guess again, yeah. Now from today we have to go through this topics. These are transformers. Now what is a transformer? So in this, what we'll do, we have two coils. One is called as primary coil, and the other one is called as secondary coil. Whenever EMF is induced in a primary coil, whenever a current, AC current is passed through the primary coil, automatically the EMF is induced in the secondary coil, right? That particular arrangement is called as the transformer, or we call it as the concept is called as the mutual induction, right? I told you in the last class that whenever I feel like studying on my own, then we call it as a self induction, or we call it as a self motivation, right? Whenever my friend is studying and I am inspired by that effect, so that particular effect is called as mutual induction, because my friend is studying, so I am also being motivated that I should also study. Similarly, whenever a EMF is induced in one of the coils, whenever a current is passed through one of the coils and the EMF is induced in the another coil, then it is called as a mutual induction. And the concept of mutual induction is used in a transformer. So in brief, transformer is an AC device used to change high voltage, low current AC into low voltage, high current AC. Remember this. This is the device which converts, which is used to change high voltage, low current AC into low voltage, high current AC. Remember this. So whenever this type of a function is done, so it's called as, that particular device is called as a transformer. Remember, transformer does not convert AC into DC. This is the big say क्या कहते हैं उसको, बहुत बड़ी गलतफहमी है. So this is a big rumor that transformer converts AC into DC. Transformer does not convert AC into DC, but it just converts higher AC into lower AC, or vice versa, lower AC into higher AC, nothing more than that. So it is used to just transform a higher voltage AC into lower voltage AC. It will not transform DC as such, right? So this is the basic concept. Now this transformer transfers electric power from one circuit to the another. Then it does so without change of frequency. Yes. Now, as I told you in the earlier class, that whatever current or voltage we are having in our home is 220 volt to 40 volt AC, 50 hertz frequency, means 50 cycles per second comes in our home. So 50 cycles. Now in this transformer, the frequency remains constant. So whenever we have a primary applying 50 hertz of frequency, in the secondary also will get 50 hertz frequency only. So it is not going to vary the frequency. Now it accomplishes this by electromagnetic induction. Now this is the concept that we have studied. Electromagnetic induction, whenever there is a current is passed, whenever there is AC current is passed through one coil, EMF is induced in the another coil. This is called as the concept of electromagnetic induction. And where the two electric circuits are in mutual inductive influence of each other. Inductive influence we are talking about. So induction comes into play. So there are two circuits. Now the basic working principle of a transformer. Let us see how it works. So as I told you that we are having two coils. The first one, the red one coil over here is the primary coil, and the blue coil over here on the second is called as the secondary coil. And this is a magnetic flux which is connecting this. And this is called as the core, transformer core, which is shown by a green line over here, right? So this, on this side, we are having a primary winding, and this is called as a secondary winding. When a winding means the rotation of a coil, or when a coil is made through a wire, that is called as winding, right? So primary winding and secondary winding is there. So in this, there are number of turns. So NP is supposed to be number of turns, number of rotations of the primary coil, and NS turns to be, NS tends to be the number of turns in the secondary coil. So we are having two coils separated, and in between that we are having some core which is of iron. So that is called as the transformer gut, and there is a magnetic flux which is denoted by phi. Now this current is passed through the primary, this is positive and negative, and AC current is passed through that, then the EMF is induced in the secondary. So this is the concept when current in the primary coil changes with being alternating in nature, right? So whenever we are passing alternating current or AC current through the primary coil, a changing magnetic field is produced, right? Now, a changing magnetic field will be produced in the primary. This changing magnetic field gets associated with the secondary through the soft iron core. So this is the iron core that we are having in between that. So this changing magnetic field gets associated with the secondary through the soft iron core, and magnetic flux linked with the secondary coil changes, and which induces the EMF in the secondary. EMF means nothing but electromotive force, or we call it as the voltage, right? So voltage is induced automatically. AC voltage is induced in the secondary, and this particular phenomena is called as the electromagnetic induction. Whenever mutual induction, actually the concept of mutual induction. So whenever EMF is induced in primary, automatically whenever the current is passed through the primary, EMF is induced in the secondary, right? So this is called as mutual induction. So these are some of the transformer models that we have. So this is actually how we draw a transformer while in a circuit. So this is called as the primary coil. It is shown as winding over here, and the AC signal, that AC symbol of AC over there. So this is IP, that is the current flowing through the primary. This is VP, voltage through the primary, and NP is the number of turns in the primary, right? And this is a secondary coil which is associated through that iron core in between. These two lines denote the iron core. NS stands for the number of turns in the secondary. IS stands for the current flowing through the secondary, right? And Vs is the voltage induced in the secondary, and this ZL is nothing but the load resistance, that we call it as the resistance or the load which is to be used, right? So these are some of the nomenclatures that are being used over here that I have already told you. So this is a model of a transformer. Then primary and secondary relationship over there. This is related to the turns ratio, that is A is defined as the ratio of number of turns in the secondary winding, that is N secondary, to the number of turns in the primary winding, that is N primary. So how they are being associated with each other, that is shown by this equation. So Vp by Vs must be equal to Np by Ns. So remember this, Vp by Vs is equal to Np by Ns. Vp by Vs means voltage across the primary divided by voltage induced across the secondary is equal to number of turns in the primary divided by number of turns in the secondary. Similarly, we can write it like current flowing through the secondary divided by current flowing through the primary, and that is called as the turns ratio, which is denoted by A. Now note this A, if it is less than 1, then we say that step up transformer. Now remember, we are having two types of a transformer, step up transformer and a step down transformer. As the name suggests, step up transformer which steps up, that is the voltage is increased, right? So that is called as a step up transformer. And whenever A is greater than 1, A is less than 1, then it is called as a step up transformer. When A is greater than 1, then it is called as a step down transformer. Whatever we call it as a step down, because it is decreasing the voltage, right? So we are going to use this step down transformer in our circuits and in your practical purposes. So all the AC/DC voltage sources are supposed to have this step down transformer only. Even we are trying to have that short-term course of designing of printed circuit board, in which we are expecting you to design the whole power supply, right, of plus minus DC power supply, plus minus 12 volt, plus minus 5 volt. So that can be done by using the step down transformer. And voltage and current angles are not affected over here, so the phase angle remains constant for both voltage and current as usual. So these are some of the principle of operation, and this is what I was telling you by mutual induction. So if you are having a coil, this is a primary coil which is given 2000 volt over here, and these are the number of turns. 1000 turns are there in this primary, and the current is flowing through this. AC current is passed through this coil, and due to this magnetic flux which is over here, this in the secondary and the number of turns which are concerned with this, we can have a 200-volt reading AC voltage across the secondary. So this is the basic concept of mutual induction, according to which an EMF is induced in a coil when the current in the neighboring coil changes. That is what I told you. Whenever a current is passed through the primary associated with a secondary, then indirectly the EMF is induced in the secondary. So remember this. This is called as the mutual induction. That is what I always tell to the students, that whenever you study in the influence of your friends, that they are also studying and they might score good marks. So that is called as a mutual motivation, and we call this in terms of mutual induction in electrical concept. So this is the basic concept of a transformer. Now transformers, how these transformers represent. So these are some of the structures that we are having. This can be in one form, that is the primary and secondary are built in the one rod itself, and we are having this core like this, and another one is like this, that windings are separate and this acts as core. So these are two constructions that we actually use. We might use some more that the same coil is built on that. This is another sort of this is another example of a primary and secondary, in which the primary is wound on the one side and secondary is wound on the other side. Automatically the magnetic flux is associated with both the coils, and the current or the EMF is induced in the secondary. It is shown like this. So this is the construction of that, and these are actually being used. And what the transformers which we are going to use are which we have a winding on one on another. So that is one way. And this is some sectional view of the transformer that is using. So cross-sectional view of a transformer. This is shell type transformer. This is core type transformer. So this is a horizontal view. This is vertical view that we are having. High voltage conductors are smaller cross-section conductors than the voltage coil. Yeah. So construction of a transformer from stampings, right? So shell type of a transformer or a core type of a transformer. This is a shell type of a transformer where we use E and L shaped say iron rods, I could say that. So, and we are put in on there because there is less leakage of magnetic flux by using this type of a concept. So these are E and this is L. So we use that, and on the center side we try to say rotate, wound the coil on this. So that is how the transformer is being made. And this is some another example of that is core type of a transformer, so that we use. Yeah, these are some of the construction details which we are not concerned with, but yeah, you can remember it for some knowledge purposes. So these are some lamination and all that we are using on the wire. So cut view of a transformer. So these are some transformers that we are having. Actually, we are having these types of transformers in our areas from where the phases are being changed. So these are all sorts of transformers. Yeah, this is another transformer that we are having, which are used for generators, right? So this can be used oil filled transformers. And yeah, working of a transformer, we have already studied this. When current in the primary coil changes, being alternating in nature, a changing magnetic field is produced. This changing magnetic field gets associated with the secondary through the soft iron core over here, and hence magnetic flux link with the secondary coil changes, and which induces the EMF in the secondary. So this is a primary coil associated with it, and AC supply is passed through this primary, and from secondary the AC voltage is used. These are single phase transformer that we are going to use, and these are transformer on load whenever we connect it to the load resistance. So these are ideal transformers on load without leakage, and these are with some of the leakage over there. So that is how they work. So I guess these are some of the variants that we are using transformer. So this is what I was telling you, E-shaped iron bars are being used over here, and the coil is placed in between this. So this is called as the isolation type, in which uh, this contains that there is less leakage of magnetic flux. If you are not using this type of a concept, then there is more leakage. So these type of transformers are being used. So these act exclusively as an isolation device, does not increase or decrease the secondary voltage. So the voltage remains constant. Usually come with an electrostatic shield between the primary and the secondary, often come with 3-wire plug and receptor, that can be plugged directly into the power outlet. So it comes with 3 wires, 2 for the AC and 3 for the low voltage low voltage AC that is being converted. So these two connections are there. So these 3 wires on this side will give you the low voltage, and this is for the AC to be connected directly to AC 220 volts, and thus it acts as a solution for that. So these are some of the high frequency transformers, in which frequencies can be taken at a higher range, but still it works as say it will give you similar AC voltage, and there will be less drop of energy over there. So these are another example, high frequency transformers. Then these are some more transformers which are used for audio range, used for primarily to match impedances between audio devices. And now this impedances, you should remember, this is a very big term, and in one of the class I will be telling you what is impedances. This is very important to match the impedances of two circuits. Remember this. See, when my qualification over here, just I need to give you this example, and I love to give this example because you might understand what impedance actually means. So my qualification is MSc, said PhD, right? So I am a doctorate in electronics, right? And now your qualification is 12th pass out. So you are 12th and I'm over here. So if I start teaching at this level, it will be very difficult for you to understand, right? From PhD level, if I try to teach you, then it will be difficult for you to understand. So what I have to do is I have to lower my qualification to your level, and then I should teach so that you can understand those things, right? So what I have done, I have decreased my impedance, right? My output impedance was very high. Your input impedance was very low. Input impedance, output impedance. So my output impedance was very high, and your input impedance is low. So what I will do, I will match the impedance, and then only I can teach, and then only you will be able to understand. So this is the basic example I love to give to tell you what is impedance. Impedance is nothing but the resistance of the circuit. So we have two resistances, output resistances and input resistance. Two resistances of a circuit. So we'll talk on that in depth in some other class. So here, these transformers which are shown over here are being specifically used to match the impedances. To connect two circuits, what we require that their impedances should be matched, right? And for that, these transformers, these type of a transformers are being used. I guess this much is enough for today. So in the next class, we'll be continuing with some more details of Kirchhoff's voltage law and current law. So today I will just refresh what we have studied in transformers. So this is the principle of operation of transformer. This was the working principle of a transformer. Then this is how the primary and secondary coils are being wound on this magnetic core, and the EMF is induced in the secondary. Just as passed, the current is passed, AC current, AC voltage is applied to the primary, and the output is taken across the secondary, right? So this is the basic concept of the transformer. Then these are some of the models that we are having. This is how we draw a circuit. So this circuit we need to draw in each and every practical that we are going to perform, because we need this. So even when we are completing your say that project of short-term course, there we are supposed to design the power supply. There also you need to draw this. So remember this, we are having primary coil, we are having an iron core in between, and then we are having a secondary coil. the AC is applied in the primary and the induced EMF is taken across the secondary. This is called as the load resistance that we have denoted by ZL. This is secondary current, this is primary current, primary voltage, and primary voltage, secondary voltage, and this is the ratio, that is NT is to NS, that is number of turns in the primary is to number of turns in the secondary. Accordingly, we have primary step up transformer and a step down transformer. Yeah, so we have this concept of if A is less than 1, then we call it as a step up transformer. If A is greater than 1, then we call it as a step down transformer. Remember, then this is the principle of operation of mutual induction. Whenever whenever AC current is passed through the primary coil, the EMF is induced in the secondary, in the neighboring coil, and that is called as the mutual induction. These are some of the examples of transformer. These are some of the core types. These are cross-sectional views. And this is the construction of transformer. Yeah, these are some more. And this is again the basic concept of how the transformer works. These are single phase transformers, and these are some of the variants of transformer that we are supposed to use in the practical purposes. So I guess this is enough for today. If you have any questions, the class is ready to hear your questions, and I will try to resolve it. So if you have any question, you can put it on chat box, or even you can put it on the comments of YouTube. Initially. So yeah, friends, thank you very much for listening this, attending this class, and I wish that if anybody have missed this class, they can view it on my YouTube channel, and I will be uploading this on my YouTube channel too. So thank you very much, and stay home, stay safe, take care. Good day, bye, see you.